There we go. I guess, okay, yeah, I guess we'll start for now. So let's see. I'm gonna assume uh you know anything about programming, so I'm just gonna go with very basics for now, at least in the beginning. So yeah, so like I said, let me just. So this is pretty much what I'm gonna be covering. So C basics, data structures and abstract data types. I'll get to that later. And then if I have time, I'll show you guys how to set up the UTR-square, which is a repo, and other libraries you guys will use, well, can use for programming your robot and creating a Code Composer Studio project and flashing it to the microcontroller, because I know it's kind of, I was trying to figure it out. It took me like 2 hours, but I figured out how to do it. So, all right, C basics. So, I guess the most basic thing is your main function, right? So your main function is pretty much everything. Everything inside the main function is what's going to be run, unless you have some exceptions, but we won't talk about that. So yeah, if you have some code outside the main function, it's not going to run. And that's the syntax for it. And let me see if I can. Okay. So I just want to like go along. So pretty much you have a main.c file. The first thing you want to do is create a main file, right? Like that. Now you can just type code here, blah, 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 and that's what will run, right? So that's pretty much the basics for it. So that's your main function. And then we're going to talk about variables and data types. So you guys might know like Python and stuff. And for variables, you don't have to specify what type of variables they are in Python. In C, you have to specify. So what I mean by specify is you can't just have a variable and assign it a number, an integer. You have to specify that that variable is an integer and then store it. So as you can see here in the syntax, right? I specify that x is an integer and that equals to 90. If I did int x equals to a, that would not work. The compiler just would complain and not run your code. So yeah, and a variable pretty much is a place in memory. So you don't know, C pretty much just interacts directly with the memory, the computer itself. So when you're declaring a variable, you're pretty much just giving a address in memory a name. But yeah, I mean, just you don't have to really know that. I mean, just so you know what that is. And I guess the reason for why you need data types is because different data types have different storages. So an integer by default occupies 4 bytes, right? So that's why you need to specify, okay, this is an integer so that the compiler knows, okay, I'm going to be storing 4 bytes. If you want to store a character right here, like the letter, that's just 1 byte. So the compiler will know, okay, I'm just worried about 1 byte. That's pretty much the reason why you have to do that. So yeah, let's go to the next slide. So these are types of some of the data types in C. So you have an integer, it's 4 bytes, float is 4 bytes, a character is 1 byte, a long integer is 8 bytes, short integer 2 bytes, and unsigned, there's unsigned long character, unsigned short character. So they're the same bytes, it's just they're unsigned. So the values are different. So I mean, an integer, which is 4 bytes, you can have 2 to the negative 32 values. For unsigned, you will go from 0 to 2 to the power of 32 minus 1, something like that. don't remember quite well. So now this is very important. So we have local and global variables in C. Local variables are anything stored like in between brackets. And those variables you can only access within those brackets. If you try to access it outside the bracket, it's just gonna tell you that it doesn't exist. And a global variable is something that's declared outside the main function and that you can access anywhere. And global variables are temporary. So once your code gets out of this bracket, it gets erased. So here I did a little demonstration. So this is a global variable. As you can see, it's outside the main function. Inside here, you have a local variable because it's inside the brackets. And here you have another set of brackets. And here I declare a local variable called local2. So this variable you can only access within this while plus bracket, right? You can access global because that's a global you declare outside the main. You can also access local1 because local1 was declared outside this bracket. And then yeah, you can still access obviously local1 in the same bracket where it was declared. But let's say if I had local2 here, local2 equals 10, that would not work because local2 wouldn't exist anymore. So that's just something you should know. And then yeah, because sometimes you may want to do that and it throws an error. So now you know that you shouldn't do that. So there's operators, pretty simple, right? So if you want to add, you just do x plus 10 or x plus y, where x and y are variables, right? Same for the subtraction, multiplication, division, modulus, and then you can just also have these increment and decrement by 1. Yeah, pretty simple. So now booleans. So booleans are pretty much it's a data type that it's either true or false, right? In C, there isn't exactly a boolean called like a type called boolean. So they, instead of the way C recognizes boolean values, is anything that's not a 0 is true, and if it's any value, any variable that's 0, it's false. So let's see if I can, I'll show you guys later, but yeah, so pretty much this, you put this in a conditional expression, which I'll explain what that is. This is pretty much considered, the compiler pretty much considers this a true, and this considers it a false. So yeah, that's pretty much the basics of booleans. And then we have Boolean expressions, which is comparing, I guess you're comparing like two things, trying to see if it's true or false. So it's an expression that outputs a Boolean value. So I mean, you can do is 10 equals to 10. Obviously, that'll result in true. If 10 is not it's equal to 9, that's obviously false. So that will output false, right? So so I guess you can, if you do like int x equals 10, oops, and then you do int y equals 9, x equals to 9, that expression will be false, right? But if you change the value of y to 10, then this expression, oh, oops, yeah, this expression will be true because they're obviously equal, right? They're the same value. Okay. So there's different Boolean I guess operators that you can use. So there's the equal, not equal, more than or equal, and then blah 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 blah. And you can use those to structure code and do like if statements. So let's say I guess a good example is for robots is if a sensor is equal to this value, I want the robot to do something. If it's not equal to this value, I want the robot to do something else. So that's kind of the application for Robotathon. And yeah, and pretty much what I was talking about, this is just examples, right? So x equals y, expression is true if x is, and y have equal values and false otherwise. So yeah, we just skip this. So and then we go into conditional statements, which was kind of what I was saying. If a sensor value equals this value, then do something. So this is pretty much, we have if else statements, which are the most commonly used ones. So we pretty much have if, two parentheses, in between those parentheses, you have a Boolean expression such as x equals y. If x equals y, then do something. So if that expression outputs a true value, then the whatever code you have in between those brackets will run. So, and then if that, let's say that the expression is false, it will go to the next else if and check, oh, okay, is this expression true or false? If it's false, I mean, if it's true, it'll do whatever it's between the brackets. If it's false, it just go to else, which else is pretty much runs if all of these other expressions aren't true. So I think I have, yeah, so we declare a variable called x. So if x is 20, do something. If you do something here. If it's not 20, okay, you go to the next one and you see, okay, is x more than 100 and is x not equal, is x is not equal to 200. So these things, this pretty much is an AND. So in order for this whole expression to be true, you have to have x is more than 100 and x is not 200. So let's say this is the expression output to false, then it goes to else and it performs whatever else you want it to perform. And then there's switch statements, which are pretty useful sometimes, especially when you have a lot of different values that you have to deal with. So pretty much it checks, okay, you put a variable here, you put switch in between the parentheses, you put a variable. And then you have different cases, right? So if the case, so let's say, so let's say case 2, if the variable equals to 2, then do this. If the variable equals, here we have case 3, if the variable equals to 3, then do something else. So that's I guess, I think I have an example here. Yeah, so you have again an integer x, you do switch x. If x is equals to 10, then do something here. If it's equal to 5, then do something here. If it's equal to 0, then you can do something here. And these are pretty useful when you have to check for like a lot of different values. Instead of having a bunch of if statements, you can just do this. But yeah. And then I guess we'll talk about loops, right? So there's while loops and there's for loops. So loops, it's almost like a if statement, but instead of doing something, if the expression is true, it performs it just kind of goes over like performs the whatever's inside those brackets over and over again. So it's like a if statement on steroids kind of. So yeah, I mean, just put while any conditional statement and it will keep running as long as that conditional statement is true. And you have to be careful when using while, because you can end up getting infinite loops. And yeah, you don't want infinite loops in your program. Well, you kind of do in one sense, but I'll talk about it later. And we have for loops, which is, I recommend using for loops when you just want to have a specified amount of loops. So you want to do something 10 times, you use a for loop. And there's an example. If you want to do something 10 times, for loop, actually, let me explain what a for loop does first. So for loop does, the first time it's run, initializes a variable here to a set value. So in this case, okay, I get to the for loop, it's going to initialize an integer named I to 0. And then you have the conditional statement here, which is the same like for the while loop. That's the one that's going to be checking for the iterations. And then you have the operation that you wanted to do every time the loop ends, right? So this initializes I to 0, checks, okay, it's I less than 10, yeah, because it's 0. Okay, so then I'm gonna do something, and once it finishes doing everything that's in this bracket, is gonna do I plus plus, which is it increments about 1. So it's gonna keep incrementing it until I is equal to 10, which is not less than 10. So this is gonna be false, and you're not gonna be running anymore. And here I'm gonna just put some scenarios where you want to use while loop and some scenarios where you want to use for loop. And then functions. Okay, functions are very, very important because you don't want to have everything in your main function because it'll get really, really hard to debug. So what you want to do is you want to separate different, I guess, sections of your code into functions. So you can do a function called check sensor value instead of having a whole block of code checking your sensor values inside main. And then also if you do a lot of things over and over again in your code, it's better just to make a function so you can just call it from main. So I'll show you guys here. So so you have here made a function called divide that returns an integer and then it takes 2 parameters, right? So here this is just going to return a divided by b. It's a very simple function, probably a little bit unnecessary, but it's just for the sake of example. So and then the way you call it is you're inside the main function, which is the one runs, right? So this function, you don't call it from the main function, it's not going to be called because it needs to be explicitly called inside main. So here we make a variable called result, and we set it equals to whatever value divide returns. In this case is 10 and 2. So it'll run this. A is going to be 10, B is going to be 2. A divided by 2 is 5, so we'll return 5. So result will a value of 5 will be stored in result. Oh, okay. Okay, now this is pointers. So this is pretty much from what I've seen, very specific to C. Java doesn't have pointers, Python doesn't have pointers. So and these are going to be really important when dealing with the robot, like the programming your robot and stuff, because our repo actually uses a lot of pointers and stuff. So what are pointers? Pointers are pretty much, it's another kind of data type, and it pretty much is an address in memory, right? So it pretty much contains, instead of containing a value, it contains an address that points to a certain variable in memory. So, but it's kind of weird because C requires you to specify what type of variable that pointer is pointing to. So you can't just have a pointer and then have it point anywhere. You have to specialize. Okay, do I want this pointer to point to an integer variable, or do I want this pointer to point to a character variable and stuff like that? And the reason, oh yeah, and the way you specify it is just like declaring a variable, but you just put a what's this called, asterisk star before the variable name, and then you can also get the address to a variable by just placing ampersand symbol in front of the variable name. So I'll show you guys how to do that. And then obviously why use pointers? You want to use pointers because they're really useful for data structures such as linked lists and trees. It makes it super easy to deal with those type of stuff. And it also allows us to change the values of variables passed in functions. Because those, like the previous slide, let me just go back. Oh, shoot. Right, yeah. So here, 10 and 2 are passed into this function, right? But if you try, well, let's just say if instead of 10 and 2, you pass, actually, let me just go into VS Code and do it. Okay. You do divide, right? And then you have a divide function here. If you modify any like of the variables you pass through there, like let's say you make this 10, if you call this, okay, that's a terrible example. 20. Okay, there we go. So you have your pass divide, x is 10, y is 10, right? You go into this function, you change y to 20, and then you get out this function. If you try to check the value of y here, is y equals to 10, this is gonna be true because you can't really, because the way it works is to pass this as a parameter, and a becomes a local variable. So it's a separate place in memory. So if you change it, you're not changing the one outside here. So in that sense, it's kind of different from Java and Python. So that's why you need pointers for that. So for example, if you just made y a pointer just like that, and then you can set the value to a pointer by doing it's kind of confusing, but you do the same thing. You put an asterisk next to it, and then you set it to a value like that. And then you have to change the function to take in pointer types instead of just integers. So, and then in this case, if you do this like that, you will actually be modifying the value for y because you pass, as a parameter, you pass the address to y into the function, and then you're changing the value at that address to 20. So now this statement will be false. So that's kind of how pointers work. You can also just do this. Instead of making a variable, you can just put an ampersand, and that's passes the address of y into this function, and it would also be able to change it. So yeah, in some of the repos, you're gonna have to have either pointers or just put the ampersand when passing in to certain functions. So just keep that in mind. Yeah. And yeah, I mean, this is just the syntax that I just went over, right? So, all right, so now we're gonna go over data structures on abstract data types, which is very important for, at least for using the repo that we're gonna give you guys. So what are data structures? Data structures are just ways to store data and represent data. There are many types of data structures. You guys have any programming experience, you probably know about arrays and maybe linked lists and trees. I mean, this is an example of a tree, right? So just store a one here, and the one has another, we call it children here, two children on either side, and you can manipulate this behavior to do some pretty interesting stuff. So yeah, I'm just gonna go over arrays because I think that's the most important, at least for the Robotathon. So arrays are just lists that contain data, right? So it's just you make an array of size 2. It's an array that contains 2 different types of values. The other thing is that arrays can only contain a certain type of value, right? So you can only contain all integers or all characters, etc. And so you access an array by using pointers, kind of. So an array, it's pretty much an address in memory. When you make a pointer, I mean, when you make an array, you're pretty much just the compiler's making the space in memory for the storage of whatever you want to store. So whenever you want to make a pointer, I mean, an array, you do this, right? So you specify what type of stuff you want to store in an array, and then square brackets, and you put the length or the size of the array that you want. And then you can specify the values that you want by doing this curly brackets like that. And then you can modify array values or also check check for values by just getting the name of the array, square brackets, and then the index that you want, right? So you get this is pretty much modifying 10. You can also have declare integer x, let's just say, and set that equals to a square bracket 2, and that'll get you the value inside a square bracket 2. So yeah, and the way you access it is it starts the first element in an array is indexed at 0, so you will have to do a square bracket 0. That will be the first element. So yeah, the first element is at 0, and then the second element and third and fourth it just one up, right? So this is pretty much how it looks in memory. So let's just say this is the memory address 100. This is how you access it, and then this is the value stored in it. And then it goes to 104 because an integer is 4 bytes, so it'll increment by 4 and by 4 and by 4. But I mean, you don't have to worry about that. I just wanted to show you guys that. And then abstract data types. So it's pretty much, you can create your own data type, like an integer, a character, and you can just create it and modify it to do whatever you want to do. So we usually in C, we have struct and enums used to create our own data types. And they're very useful because that's pretty much how every single library is. So you have a library, and a library creates its own data types that you can use. So you if you see one of our source of files in the on a repo, you'll see that we use a lot of structs and enums. And yeah, so they're yeah, like I said, UT-Raspberry has a lot. And if you have experience with Java or C++ or any other object-oriented programming language, classes are pretty much abstract data types. And the structs, well, I'll go over it, but structs are pretty much like classes, but without functions. So enum, right? Enum is just a way to create data types. As you can see here, I can put enum, call the data type Boolean, and we can specify, okay, if it's true, or like if you type true, then that equals to 1. If you type false, that equals to 0. So that pretty much, you can do this. Boolean x equals true, or you can do Boolean x equals false. So you pretty much just created your own data type, which is pretty neat. And then structs. The structs are very important. So it's a way to create a data type, but it has different types inside of it. So I guess the perfect example is a coordinate, right? For a Cartesian coordinate, you have an x value and a y value. So I created this data type called coordinate that contains two integers, int x and int y. And then the way you access it is you can do p.x equal to 20, p.y equals to whatever value you want. So that's pretty much what a struct is. You can just make your own data type. And it doesn't have to be like all integers. Instead of an integer here, you can have a character, or you can have a float, right? You can have any type of data type here. You can even have a data type you created yourself inside another struct. So, and then you can also, whenever you have a struct, you create a struct, but of a pointer to a struct like this. So I put asterisk before the p because I want to make a pointer to the variable p. So if you want to modify that, instead of doing the dot, you have to do a dash, well, just an arrow, right? An arrow x, and then that's how you modify it. All right, so I'm gonna show you guys how to set up the libraries that you need for programming the robot. So you might know about GitHub, if you don't know about GitHub, I highly recommend you create an account because it makes it, well, doesn't make it. You need an account in order to clone the libraries that we're gonna give you guys. So yeah, it's free. It's pretty simple to do. And GitHub is pretty much a place where people can upload their code online and then have other people download it without being such a hassle. And then also it lets them keep record of all the code that they're working. So pretty much any companies that have software, which is pretty much every company nowadays, uses GitHub for that. So yeah, I was gonna show you guys how to clone repositories right now. So this is the repository that we're gonna be giving you guys. It's called UT Raspberry. The link to it is right here. I'll post the slides later. I'm pretty sure it's somewhere in the link tree. So yeah, so it's pretty much by cloning it, it means that you're getting all the code that we wrote and upload it online, and you're gonna download that to your laptop or computer and be able to use that code. So if we go ahead and click on this link, it takes you here, right? So if you already have a GitHub account, you can just go to code, and then you can clone it several ways. If you're a beginner, I highly recommend just downloading GitHub Desktop, because you can just click here, open GitHub Desktop. Oh yeah, there we go. Well, I already have it cloned, so that's a problem, but yeah, you can just go here, click on open through GitHub Desktop, and then it'll open the app and it'll tell you just to clone it in a certain location. You can also do it through the command prompt. So you can just type command prompt, open it, and you can just go to anywhere where you wanna. This is kind of more complicated because you also have to install Git, which is a little complicated, but I mean, you pretty much just go to your directory that you want to install it and just do git clone, and then just copy this link and just paste it in there, and it'll clone it for you, just like that. So yeah, please do make a GitHub account and clone the repo, because as you can see, this repo has examples. So you wanna, I know for the motors, you will have to use the PWM library that we have. So if you don't know how to use that, you can just go to examples and then check here. Okay, so this pretty much tells you, if you copy paste this into a project and try to run it, it will run just fine. But I highly recommend just going over and trying to understand. We have some comments here, so you know what everything does for the most part. So, and then it tells you at the top, okay, this is how it, yeah, so where's it? Yeah, so we have comments here that tell you what everything does and what the program's supposed to do. So yeah, right here. This program demonstrates initializing the TM4C PW module, flashing an LED with it, and updating its frequency. So you just go through this code, and depending on what you want to do, you can modify this code to do whatever you want to do, right? You can also start from scratch, but that will be a little bit harder. So I just recommend just looking at the example, copying into your project, and just modifying it to do what you want to do. And then here are the libraries. So yeah, I mean, if you want to do that, you can go to the pwm.h file, because that's where all the documentation is. So this one will tell you like all the stuff that you need to know. It has, like I said, enums. It creates its own data types. So we have a data type called PWM source. You have another data type called PWM config, which is how you need to fill. I'll show you guys how to initialize it right now, but yeah, it tells you what every single variable is and what it's supposed to do. And then it tells you, and then it has these functions that you can call from your file. And those functions will just, for in this case, it will just update the configuration. Here, it will stop the PWM, which is just pretty much stopping the signal. So in the case, if you want to run a motor, if you do PWM stop, it would stop the motor. So yeah. So I guess, actually, hold up. I'll show you guys how to create a Code Composer Studio project and flash it with to the TM4C and run the code. Because I know it's kind of complicated and annoying, so I'll just show you guys how to do it. Just give me 1 minute. Documents. All right. Oh, wait.
You also attach the link to the GitHub. It's in the Robotathon chat.
There we go. So, what you have to do is just open up a project, just do a new CSS project. So, here you have to specify the microcontroller we're using. So that's the TM4C. I think I have it somewhere here. So yeah, so creating a CSS project, you have to copy this because this is the whole name of the microcontroller we're using, and just copy paste it in here, and it'll get you this option. Just select that, call it whatever you want to call it. Okay, that's not that. And then I recommend that you put this project inside the repo that you cloned, right? So the UT Raspberry repo, which I have no idea where I cloned. Wait, hold up. Okay, here it is. So I would just make a folder, call it okay. And then I just call it project. Project 1, right? And you just select that folder and create this project there, and just click empty project with mains.c, and they'll create the project for you. There we go. So now you're gonna have this. So what you want to do first is you want to be able to link. So in order to use the libraries, you're gonna have to do the #include command. So if you check so let's say we want to turn on an LED in the TM4C, because the TM4C has a built-in LED on it. So if you want to turn it on, okay, let's just check the libraries. you're gonna want to use the GPIO library because that stands for general purpose input output. So in order to turn on LED, you need to give it a signal, like I guess send a voltage that will go through LED and turn it on, right? So that's exactly what GPIO does. As you can see, there's two files here. One's the source file, which is what contains the code that runs, and the other one's the header file, which contains like the functions that you can run. So you want to link to the header file. So the way you do it is you go to the raspberry. Okay, it's lib, and then it's in the GPIO folder, and then you want to link the GPIO header file, which has an extension of that H. So you do lib GPIO and then GPIO.h, which is the name of the file. And then there's another library called PLL that you wanna always connect to, because without it, the microcontroller just doesn't work for some reason. So always link the PLL.h file, which is also here. So if you look for it, it's like right here. But now you're gonna have to go to, so you go to project, oh, correct. And you go to properties, and then you go into build, ARM compiler, include options. And then what you're gonna do is just click on add and just do .. and press OK. This makes it so you can actually access the files. Don't ask me why, you have to do it. So yeah. So yeah, just remember to do that, because if you try to compile it, it won't find these files. Okay, so now we have these files. Now we have to add the source files. Yeah, I told you guys it's really annoying, but so now you have to add the files, right? So you go to the place that it was, and as you remember, there's two files, right? So you want to add the source file to it. So just click on that. Make sure it's linked to files, not copy files. And then just check that. Press OK, and now you link the GPIO file, which should be here. Yeah. And then you also want to link the PLL file, so you want to do the same thing. You do add files. You go to the PLL folder and add the PL source file. And if I'm going too fast, let me know, because I know it's a lot, but I'm recording it, so you can go see the recording later. And then also you have to make sure, because sometimes you're inside the GPIO files and inside the PL files, there's another includes, and you have to check. Okay, so as you can see here, there's this include that requires this file, right? So you had to also include that file. So what you would do is, okay, this is in library fault handler, so you just add that file, like just like the other files. So you go to library fault handler, add the source file. And the reason for that is because this file, which is the GPL.c file, is using this specific file or library, so you need to include it too. And then we can check the and yeah, also regdevs too, so you gotta add that too. And then that's in the inc folder, regdevs. And if it tells you this, just close it. And this ones you don't have to worry about, because these are general imports. So this is from the C library, so you don't have to worry about those. And then you can also check on PLL. Okay, what files does PLL need to use? Regdevs, which is already there, so we don't have to worry about that. So now we can start actually programming and coding some stuff. Actually, almost. So I told you guys it's really annoying, but you have to also make a target file. I won't go in detail into like why, stuff is just make a file. And I recommend just put it in the location that the project is. So just on the RAS project. And you can name it whatever, it doesn't matter. And what you want to do here is the same thing. You want to just copy paste the name of the microcontroller and then just select this. And then for the connection, you want to just scroll to this thing and just find the Stellaris in circuit debug interface. So you want to do that and then just save it. And then one last thing you have to do is go to run, debug configurations. You go to this thing called Code Composer Studio device debugging, right click on it, new configuration. And under target configuration, you have to specify the file that you just created, right? So root your raspware, project one, and this is the target file that I just created. So you just select that, apply, and now in theory you should be able to just now you should be able to just code and flash it to your TM4C. So now let's just say we wanna turn on the LED on the TM4C, right? Wait, what time is it? Okay. So we check, you can check the examples, or you can also check the, oh. You can check the header file. So this is, I think it's better in the long run because like sample codes don't include all the features that the library has. So I'll just briefly go over this library because it's pretty simple. So we have here, we define a type called GPIO pin. And these are all the pins that you can use. So you can just select any pin. The TM4C has like the pins labeled. So if you want to use pin A0, you would just find the pin that's labeled PA0 in the TM4C. And then we have a struct here. So this is used to initialize the pin. So in the struct, we have pin. So we have a variable called pin of this type. So this pretty much what this is you have to specify what pin you want to use. So that's what you would put for pin. So actually, let me just go back to Code Composer Studio. So we want to make a GPIO config T, and then just call it LED, right? And then you want to initialize it to some value, well, some values, right? Because since it's a struct, it has several values. So the first value is the pin. Okay, what pin do I want to use for this? In this case, the built-in LED pin is an F1 pin. So you would just put the pin underscore F1. And then, oh, okay, there we go. Just put it there. Now the second field is GPIO pool. Just don't worry about this. You probably won't need it, but if you're using the onboard one, just put GPIO pull down. Just put it in here. And then you go to the next one. Okay, is output. It is an output because you're outputting a voltage to the LED. So you put true for that. So you just put true. And the reason it's true is because it's a bool, which is a type that we made that contains true or false. It's pretty much the one I showed earlier in the slides. And then alternate function. For the alternate function, you don't have to worry about that. Just put the default. So default is 0. Just put 0. What is this turn off? I don't know. 0. It's analog. Just put the default false. False. And then GPIO dry, just put the default unless you're specified to put something else, just put the default. And then I think the other one, yeah, this is the last one, enable slew. Again, if you're not specified to use it, so don't use it, just put default is false, so just put false. There we go. Now, if you go back to this file, we can see, if you scroll down, GPIO, there's a function called GPIO init, which initializes the GPIO port. So you want to call that before actually using the pin. So just do GPIO init, and then if we check here, we see that it takes an argument of type GPIO config. So just pass the configuration that we just did here, which is called LED, and just pass there. All right, so to pretty much we configured the pin to be an output at pin F1, which is a pin somewhere here. And then what this does, it initializes that pin to be an output. And then we can check, okay, what other functions are here? We have GPIO set bit, which is pretty much sets the pin to either send a value of 0 or 1. So if you want to send a value of 1 in order to turn on the LED, so we want to call this function in our main, and then pass the parameters that they want us to pass. So they want you to pass the pin that you used. The pin was, again, pin F1. So you pass that as a parameter. And then the second parameter is bool value. So if we see here, value 0 is false, 1 is true. So you want to send a high voltage, which is equivalent to a 1 in computer language. So you put true. So now in theory, I should be able to compile this and get no errors. No errors. Okay, perfect. So yeah, you have to build the program before flashing it, and then you can just connect this. This is just how we do it. I just connect it to the computer, and then make sure it has the little thingy here, this LED to be on. If it's not on, just this switch, you can flip it, and then it'll turn on eventually. So now you can go to flash. So just click flash. And it should be, okay, perfect. As you can see, it's now red because that's the LED I turned on. So yeah. So yeah, this is pretty much what I did. I sent a signal to turn on this LED, and the LED that I turned on was red. Now, if I just change the port to F2, which is, I think, the blue LED on the board, it will turn on the blue LED now. So if I flash that and run it, it should run a blue LED now. And yeah, I mean, that's pretty much how you create a project, connect, do all the stuff that you need to do to run stuff, and then just how to do stuff on your microcontroller. Now imagine instead of turning on a LED here, you send a signal to a motor, and then that signal makes the motor spin. So that's kind of how you guys are gonna make the motors move and stuff. So it's just a very, very simple example of what you guys are gonna be doing. So yeah, if you're doing the software for your team, I highly recommend going over all the different libraries that we have. And then yeah, if you have any question of what something does, just let me know. I have my Discord. Wait. Yeah, so I have my Discord here at the end. So send me a message and I'll try to help you, or just go to my office hours and I'll help you out. Or you can just go to other people's office hours that are also proficient at software, and they'll help you out. So yeah, I mean, that's pretty much it. You have any questions, let me know. And then the Zoom people, just please type it because for some reason I can't hear you all. Let's see, okay. So yeah, no questions. Okay, no questions. I guess I'll stop the recording for now. So yeah, I hope that helped you guys get a little familiar with C and get you familiar with how you will create a project and run your code on the microcontroller. So yeah. All right. Okay, that's about it. God, I'm
General
thirsty.
announcements, the motor checkpoint will be moved to next week because we're extending it. But also on Monday. Well, if you're on your way out later on the second floor, we're having a corporate meeting with Texas Instruments, and yeah, it's at 7 on Monday. You can RSVP there. Most likely they're gonna. So yeah, and do you think that's good? Yes. Yeah. Yeah, they're buying, so hopefully it's. But yeah, next week's checkpoint will also do which time. So how you guys are starting to about like we're not gonna require y'all to have it done by then because we haven't like that. But if y'all have a SolidWorks CAD, that's filled, but you just have to schedule. More than likely it's as long as that's why you put stuff. And this is excluding like if you're doing